All right, so in this video, we're going to talk about how to graph exponentials. So the last one was about logarithms, this one will be about exponentials. So something I wanted to point out to you that we kind of talked about a little bit before. When you're graphing those logarithms, the reason that we needed to solve it for x to make it easier is because if we were to rewrite this example, y equals log base 3 of x, it would be 3 to the y power equals x, meaning that if I were to plug in x values here, I'd be saying 3 to some y power that I now need to figure out equals -2. And I don't know about you, but that seems like kind of a pain in the rear to solve to figure out what values are going to work. So we solve this equation for x because it makes it easier to plug in and say, okay, I'm going to plug in values for y now. So 3 to the -2 power equals x. That just makes a lot more sense than trying to go this way. So that's why in logarithms, we plug in values for y instead of values for x. So it's just based on the idea that plugging in for the exponent is easier than plugging in for the answer. Now down in exponentials, x is the exponent. So it makes sense for us to plug in values here instead, because 3 to the -2 equals y, and we can solve that. So we're going to get started. So this one you're not going to have to solve like we did with logarithms, where you had to solve the equation for x. You're just going to take it as it is and plug in your values. Now, a couple things to notice. Number one, we will have transformations just like we've had before. So if there's a number right here in front of our exponential, that would be an a value. If there was a number here, which there is in this case, that's an h or a k. So just like before, we're going to put a value in the middle of our table. You're going to want to put your h value in the middle. So I'm going to plug in 2. Give you a moment to figure out why it's +2 and not -2. Okay, so then we're going to pick 2 values below my x value, or my h value, and 2 values above. And I'm just going to plug them in like normal. So 3 to the 0 minus 2 would be 3 to the -2 power minus 2. Then I'm going to plug in 1, so 3 to the 1 minus 2, which is -1. And then 3 to the 0th power, 3 to the 1st power, and 3 to the 2nd power. So now I've got coordinates I can graph. Hopefully those coordinates are looking super familiar to you, because they should look a lot like a problem we did in the last video. So 3, 1, and 4, 7. And now I've got an exponential graph. And just like before, when we talked about when you get coordinates that are super close together like that, that's telling you where your asymptote is. So I'm getting closer and closer to -2, but I'm not quite there yet. So my asymptote is going to be at y equals -2. So just a brief overview again. Figure out your transformations. Your h value is going to kind of tell us where that elbow of the graph is, that point where all of a sudden things are shifting, comes from your h value, where we switch from being super flat to going up at a really fast rate. I like to call it like the elbow of the graph. So that comes from right there. That's why it goes in the middle. We pick 2 x values below, 2 above, plug them in, find all of our points, and find the asymptote. So trying that again. So figuring out my a value, there is no a value, my h value, and my k value. I'm going to set up my table. H goes in the middle. It's going to be -2 in this case. Again, I'll give you a minute to figure out why it's -2 and not +2. Pick 2 values above my x value, or my h value, 2 below. And now I'm going to just plug them all in. So again, if you're trying to do this along with me, I'm using a calculator to figure out these numbers. I'm not just doing it. So -4 plus 2 is -2. 1/3 to the -2 power is 9, plus 2 is 11. 1/3 to the -3 plus 2 would be the -1 power. That's 3, plus 2 is 5. -2 to the 2 power, that'd be 0. So 1/3 to the 0th power is 1, plus 2 is 3. And -1 plus 2 would give us the 1 power. So 1/3 plus 2 would be 2 and 1/3. Then I'd plug in 0, and I would get 1/9 plus 2. So those are all of my coordinates. Again, I noticed that my graph is all of a sudden getting really, really close to one particular number. So I started at 3, and all of a sudden I'm getting really, really close to 2. So my asymptote is going to be at 2. Hopefully you're looking up at your equation and noticing why it would be getting really, really, really close to 2. So then 2, we're up at 3, 5, and 11. So hopefully my stalling here has given you a chance to figure out why I know it's flattening out at 2. It comes from our k value. So our k value will tell us our asymptote, which in this case is 2. All right. So I want you to give this one a shot. Y equals 1/2 to the x minus 1 minus 1. See if you can figure out your transformations, your h and k. Figure out what goes in the middle. And see if you can find all of your coordinates. Now, if you're looking for an answer to that last one that we had, that's why you're here. Those should be your coordinates for that last one. So our graph would end up looking like this, where the asymptote is at x equals 1, and the graph goes up from there. Don't forget your arrows. So when you're all the way done, you should be able to graph both of these, and then you're going to check your work with me, and then you'll get some practice problems.